Okay, well, that is a full and generous 2 minutes of grace period, so I'm going to go ahead and get started. Again, Steve Hines, founder and CEO of EnergyCAP, Inc., and I thank you for joining us today for the ins and outs of campus energy data. We've had over 100 people register for this, so it's obviously a topic that is very relevant and important for those who are charged with managing the energy data and energy management for college and university campuses. All of the attendees are muted. You don't have any way to speak to us verbally, but you can use the questions box on your control panel and submit comments or questions. If we have time at the end of our regularly scheduled Q&A session, we will get to some of those questions. We probably won't have time to address all the questions that might be submitted, and if any of those are particularly relevant to the entire group, we will send out replies to those questions when we send you the follow-up email. We're recording this. Your follow-up email will have a link to the recording. You'll get that in a day or two. So if for anyone who not able to attend the whole thing or who has missed it entirely, they will be able to watch the recorded version. And also, of course, the Starbucks gift card will be emailed to you in the follow-up email. I would say that everyone will get a Starbucks gift card unless you drop off in the first 5 minutes of this presentation because you actually feel like running to Starbucks. Let me move on and introduce our guest speaker today. Lalit Agarwal is with us today. He's very generous with his time, and we appreciate that very much. He is the Director of Facility Systems at the University of Nebraska at Lincoln. Lalit has been a very successful and very resourceful user of EnergyCAP over about the last year, and he's going to relate some of his experiences to us and go beyond that. This isn't all about EnergyCAP. A lot of it is about some of the challenges and solutions that he has used to very effectively manage energy programs at University of Nebraska main campus in Lincoln. So Lalit, again, we're very appreciative of your time and the insights that you can offer to your colleagues around the country, and let me turn it over to you.
Thank you very much, Steve. As Steve mentioned, majority of the content of this presentation is going to be generally about the energy program at University of Nebraska at Lincoln. And the idea is going to be how we structure our operation and integrate our systems to achieve the operational and energy efficiencies at our campus here. Just a little bit about University of Nebraska-Lincoln. It was chartered in 1869 as a land-grant institution. In 2016, we had about 23,000 students, and the space profile is also shown on the slide in front of you right now. Specifically within facilities, we have the various operational groups in utilities, maintenance, custodial, landscape services, sustainability, controls, and energy management. In addition to that, we also have some supporting units that help with those operations, like planning, design, and construction, the business office, and the facilities system, which primarily consists of data and business analysts. This is pretty typical at most campuses. There is one thing unique at University of Nebraska-Lincoln. We have this entity we call Corp, which is really an intergovernmental agreement between University of Nebraska and Lincoln Electric Systems, which is a local utility provider for us in the city of Lincoln. And it is a government-owned operation. It is not a privately owned operation in Lincoln. LES primarily provides us help with bulk energy procurement, setting rates, forecasting, and some accounting assistance. And they also serve as advisors for operational improvements to our utility plants for curbing our electric peak demand and things of that nature. It kind of serves as a standalone entity where all the purchasing and consumption goes through this entity we call New Corp. Before we go any further, I want to give a little quick history of where we have come from. So going back to early history, University of Nebraska-Lincoln, in our knowledge, is unique where we have our own building automation and energy management system. And when I say we have our own, I'm talking about all the way from the front end that a controls engineer or an energy engineer would use down to the embedded controller that's hanging on some room as a thermostat or controlling a major piece of equipment like an air handler or an exhaust system. In early 2000s, we had a merger of controls and maintenance, and now controls is sort of part of maintenance organization. A few of the things that we have done in early history is instead of trying to value engineer everything, we decided to come up with design guidelines. Those were developed and implemented so we can hold the contractors who do business with the university accountable for proper installation and commissioning. We also have large improvement project construction team, which was developed for controls, card access, and fire alarm. The original idea was for controls because being that we had our own system, we couldn't hire a third-party contractor to come and install those control units within our newly constructed or renovated buildings. The big idea behind the whole program that we have at Lincoln has to do with this energy mindset of and. What we do here in Lincoln is we take the approach of integrating our systems, our processes, and projects to achieve our strategic goals of energy saving, operational saving, but at the same time maintaining occupancy comfort for our occupants so we can serve the primary mission of the campus to provide a comfortable learning environment and research environment for our faculty and staff. This is a very high-level list of energy projects that our campus has engaged in for the last 15-20 years. Probably very familiar to most of you in attendance. Couple that highlighted are scheduled off overnight and weekends wherever we have systems that allow us to do that. Another big one we have is the occupancy sensors. And all the new buildings that we commission anymore or any renovations we undertake, we require an occupancy sensor, not just for lighting control, but also for air control. In addition to that, we also do overnight and weekend deadband, again, where our systems allow. Go a little deeper into improved HVAC controls. We have scheduled night and weekend setbacks and shutdowns. We also do set point resets where all the rooms that are being served by a single system vote for whether or not the supply air should be warmer or colder. We typically discard a few outliers and go with majority of the rooms and what the demand is. In addition to that, we also do alarming and monitoring, including preventative maintenance monitors, and I'll discuss that a little bit more in another slide at a later time. One other thing we have in our system that may be a little unique is as soon as any point is created in our building automation system, we have complete automatic trends. We do not have to actually go ahead and enable any trending. We allow trending to happen all the time, and data is collected for all control points. Most of the data is saved for about 5 years, so we can go retroactively and look at how the same system was performing a few years ago. Here's an example of the occupancy sensor. Being that it's a learning campus, we have faculty and staff who are typically not in their offices, but they're in classrooms teaching or in their laboratories doing research, in which case their primary offices are actually unoccupied most of the time. And the chart here shows how the occupancy varies during the day, and the difference between the red line and the blue line is the savings in energy for us. And what we do in this situation where the room goes into an unoccupied mode is we allow the room temperature to float in a 2-degree deadband, and we also reduce the minimum ventilation. If we have a room that does not have an occupancy sensor, we have learned that a typical payback for taking on that project is about 3 to 5 years. Here's a quick view of where our system integrations used to be back in 2014, 2015. We have various systems. The SAP and Archibus system are our system-wide enterprise applications. The ones in green, the eBuilder, TMA, Deltek, and Building Automation are department scope systems. The Wonderware system is the SCADA system we use in our power plant. And we also have some customer-facing systems like Lucid for dashboarding, and BAMS is another custom program that I'm going to elaborate about in just a little bit. The big idea about this is these systems typically come standalone, and they have certain functionality out of the box. What we have decided is the real power is when we are able to make these systems talk to each other. Sometimes the vendor is willing to provide that integration or has that integration built in, but a lot of times we have written our own integration pieces that have allowed us to take advantage of additional opportunities for operational efficiencies. Specifically, the TMA system, which is our work order system, tied to building automation system, which is our, again, homegrown system, has created a lot of opportunity for efficiency improvements, and I'll explain that just a little bit. So here's an example of our building dashboard. This is through a company, Lucid, and it basically allowed us to put our consumption information on a website, and it also allowed us in some locations to put it on building kiosks on big flat screens. So if the kiosk happens to be touch screen, the occupants can actually interact with this dashboard to look at what their energy consumption is. The other thing we did, since we have our own building automation system, the advantage was we were able to pull in the utility plant information into our system in building automation and make it visible to all the control operators. The screen that you're seeing is our thermal energy storage tank that shows the capacity of the thermal energy storage tank, and it's coming on and off. Sometimes it's very useful to know that we are switching from our chiller system to a thermal energy storage system, and the blip that we may see on the building site can be attributable to that changeover. Here's the custom software that I was talking about earlier called BAMS. It stands for Building Automation Monitoring System. Typical building automation systems are not as user-friendly if you really think about it from a user perspective. So we created this very user-friendly application that ties to our building automation system, where we allow the researchers or the occupants to monitor the environmental conditions that they care about within tighter boundaries for whatever schedule they want, and they have complete control of how and when the notifications are sent to their own emails or text or pagers or any other systems that they may choose. It allows them to set tighter controls than what we as stewards of the facilities care about. They may have research that is more temperature sensitive or humidity sensitive, that they are allowed to become the first responders to their space. The other thing, as I was mentioning earlier about integration, how it drives energy savings and operational savings, we had a semi-annual fan pump motor preventative maintenance set up. So the calendar depicts that we would religiously do it in June, December of each year. We tied the building automation system to our computerized maintenance management system and started pushing our run hours into the ticketing system. And what it did was it reduced our frequency from 6 months to about 10.5 months for all these pieces of equipment, while we still maintain the same level of serviceability that's recommended by the manufacturer. This resulted in about 30% operational savings versus our calendar-based PM approach. Here's another example of how integration drives energy and operational savings. In addition to pushing the run hours from the pumps and motors, we also started measuring differential pressure across air handling unit filters. And first we started procuring better quality filters, and then the building automation system measured what the pressure drop was across those filters. And when they plug up to a certain level, it automatically pushes the data into our work order system that generates an automatic ticket and allows the preventative maintenance team to respond to those tickets. Overall, it reduced our labor hours by about 55%, and we were using 50% fewer filters, resulted in energy consumption reduction and also better environmental stewards. And then, as I mentioned earlier, our strategic goal is not just energy and operational savings, but also to provide better comfortable environment for our customers, and this approach also improved our indoor air quality. So those were the things we were doing before 2015, and we never had an organized recommissioning program for our building equipment. We kept on adding more equipment, more controls, more smarts into our system, but we let it drift a little. So in about 2015, we chose to create a formalized recommissioning program with a goal of recommissioning about 6 buildings a year. And some of the savings that we get from recommissioning, we didn't want to lose them to drift again. So at the same time, we also implemented a fault detection and diagnostics program, partnering with Iconics. And some of the results are on next few slides. So this is the best example of our recommissioning effort. This is an International Quilt Museum. It's a very humidity sensitive building because of the contents of the museum. The original building was about 38,000 gross square feet and used about 10,500 units of energy per year. During the addition of the building, it increased in gross square feet by 36%. But while we were commissioning the new addition, we also recommissioned the existing building, and the recommissioning effort reduced the total energy by 25%. But when you account for the increased gross square feet, the actual EUI reduction was about 45.1%. And here it shows the other buildings that we have recommissioned till date. And overall, we are seeing about 17% reduction in energy cost. However, if you see the chart, it also shows that not every building actually realizes energy savings. In fact, in some cases, our energy savings energy usage goes up. And the reason that happens in some of those cases is because in those instances, sometimes the equipment wasn't even functioning, and we didn't act on that because sometimes the occupants didn't complain. But as I alluded earlier, our goal is to make sure that we create a comfortable environment for our customers. We decided to make sure that the building is recommissioned to the design specs again. And then, as I said, we chose to implement a FDD program on top of our recommissioning effort. And this was the implementation process. We first chose to align our building automation system assets and integrated with Iconic software. One of the challenges was because we have a custom building automation system, we had to write a gateway that allowed Iconic software to pull data out of our building automation system. Then there was a huge effort in trying to develop fault prioritization algorithms, both from the cost and criticality perspective. In some cases, when the costs were low, they may be in a research-sensitive building, which required us to respond to the fault faster than maybe even a higher cost fault. When these faults come in, we have a control center that does the triage, and they primarily use the building automation system to identify the root cause of the problem. If they are able to resolve the issue remotely, they take care of it right from their desks. But in cases when that is not possible, they choose to then dispatch field technicians based on, again, the prioritization of cost and criticality. Here's an example of a typical fault that we had show up sometime in February. So the yellow highlighted record shows that in our law college on floor 2, room 272, we had a VAV not following command fault. And if you look at the fault cost at the rightmost column, it showed about $220 per year in wasted energy unless we fix this fault. Now, $220 a year may not sound much, but this is just one room, and there are thousands of rooms on our campus that could have a similar situation, so it could become a big issue and potential for significant savings. So let's take a little bit of a deep dive into this particular fault. So as I mentioned, if not repaired, this fault wastes about $220 per year. So when the fault showed up, the control center first pulled up the systems on the building automation system side, and they opened the trends, which were again automatically trending all the time. And just to get the context right here, the blue line on the top chart shows the room set point, the red line shows the actual temperature, the black line on the bottom chart shows the VAV feedback, green shows what the VAV box was commanded to, and the purple shows reheat command, and the blue shows reheat feedback. So if you look at this, the room was in normal cooling condition just before, somewhere between January 20th and 21st. Somewhere around this time, the VAV failed and failed full open, which meant we started dumping a lot of cold air into the room. And basically the room became a constant volume full cooling with reheat system, because the reheat kicked in to compensate for the additional cooling that was being put in the room. The response from the control center was they basically created a work order for a zone technician to go and replace the VAV actuator, and that basically brought it back to normal. That's an example of how we were able to respond to that fault. So we had our energy program. We had a lot of metering in place. We were trying to push the boundaries by decommissioning and even minding it with the fault detection and diagnostics. One of the challenges that we still had was the energy data that we were collecting from our meters was very fragmented. It existed in some Access databases, it existed in some Excel spreadsheets, and then it existed in some actual databases. The challenge became that whenever a question gets asked for a particular report, we had to scramble to figure out how we're going to respond to that. And about a year and a half ago, we were tasked by our leadership to make sure that we were able to put all of this information in one place, so we were able to slice and dice the data the way we want, the way we needed to. So here's a general overview of how we went about implementing EnergyCAP. So we took all the consumption meters which included interval meters that were tied to our building automation system, manually read meters because there are some still that we have our utility technicians go out and read once a month. And then we also have meters that are provided directly as a service from our vendor, and they do not go through our utility plant. In addition, we have our interval data from our production meters from the SCADA system at the utility plants. Some are manually read, and again, some are provided from vendors for the bulk purchases of commodities that we do. Once all of this information is put into a single database, which happens to be EnergyCAP in this particular instance, we were able to do a lot of analysis from energy engineering point of view by calendarization, normalization, tracking energy projects, performing metering audits, and also performing cost avoidance analysis. From vendor bills point of view, we were able to, instead of taking the vendor bill and doing data entry, we were able to scan those bills and upload it to EnergyCAP, and they do the data entry for us, and also attach the image of the bill along with that entry. What this allows us to do is also, it allows us to do ad hoc reporting. You can slice and dice the data however you want. And I'll show the next slide that we also linked it to Archibus, which is our primary space information database. EnergyCAP included a bunch of canned report that we were able to use, and they also provide a custom reporting tool if we had a specific need that was not being met by the canned reports. Another, and in some ways, one of the biggest benefits of implementing EnergyCAP at Nebraska campus was to perform our auxiliary chargebacks. So as I mentioned in one of the first few slides, we have a big chunk of our users are auxiliary customers, meaning that they reimburse us for the energy they use. And it used to be a very manual process before EnergyCAP was implemented. But since then, we are able to do bill audits. We can create invoices and post it on a portal that the customer can come and download it directly. And we also created integration with our enterprise accounting software, SAP, which allows us to push a button and generate the information that can be sucked into SAP for all the chargeback information. In addition to that, we are also looking at improving our reporting inside the utility plant and performing some efficiency audits there. Another advantage of a tool like EnergyCAP is it allows us to do tracking of energy projects and visualizing the energy savings. This is a chart for the same quilt house building that I talked about a little earlier. That was our first building we recommissioned. And you see the marker in the middle of the chart there. That is a marker that displays when the recommissioning happened. And it also then shows how our energy use index has gone down since then, and we are able to maintain it with our fault detection and diagnostic tool at this time. Here's another example of how EnergyCAP allows us to visualize the data where, and without going into too much detail on this, here's the actual use that we had, but EnergyCAP is saying that if we normalize for weather, change in square feet, and change in utility rates, we would have actually, we ended up actually saving about $6,000 this 1 month in this one building alone. So coming back to this system integration point of view, the idea again is each system has its own strength and it's capable of performing its function, but it's the integrations that allow us to push the boundaries of what each of these systems can do, and the systems together are able to give us better than some of their each functions. And as this shows, we were able to integrate our building automation system with EnergyCAP. Very recently, we have even started pushing interval data into EnergyCAP that will allow our energy engineers to keep an eye on changes to meter usage as time goes on. And as I mentioned earlier, we have our SAP system integrated with EnergyCAP, so a push button creates our chargeback sheet monthly that can allow us to recoup our costs from our auxiliary customers. So let me talk a little bit about our current and future initiatives. So all that I talked about till now was what we have done either in history or recent past. These are some of our current initiatives and upcoming initiatives. So one of the things we are working on currently is we are trying to integrate the reservation data from our campus room scheduling system that will allow us to automatically adjust our air handler unit schedules. What that will do is it will match our building equipment operation to the needs of the academic units. It will also help us reduce energy because the air handling systems will not be running at their highest level when the space is unoccupied. The occupancy sensing that we have helps at the room level, but this will help at a building or a system level. And it will also save some operational dollars because it will eliminate some manual updates of air handler schedules that happen typically every semester. There is usually some changes to when the classes are scheduled in a given campus, a given building or a given part of the building. One other thing that we are looking at right now is to replace our chill water control valves with smart valves, which are programmed to maintain a minimum temperature differential across the coil. The goal is to try to extract maximum cooling energy from each gallon of chill water that flows through those coils. It will help reduce the pumping energy from our central utility plants, and it will help with our campus peak electrical demand reduction. Another initiative we have is fume hood and lab initiative. We are using the data that is collected by our building automation system to identify labs that are not being properly operated. When they are not properly operated, they could be operating in an unsafe condition, and it could be doing it at the expense of extra energy usage. So proper sash operation, proper standby, and proper lab occupancy switch usage is something that is monitored by our system, and we are sharing that information with our environmental health and safety department so they can train our researchers for proper use both from safety and energy conservation point of view for how to use the labs and the fume hoods. We want to use the partnership we have with our environmental health and safety folks because then it would be a single consistent message that's shared with our researchers. So to go back and talk a little bit about the energy mindset of ANG, I hope that it was relatively obvious, this approach of taking our systems, processes, and projects and working them together to arrive at our strategic outcomes of energy saving, operational savings, and occupant satisfaction has been the driver behind this. And what makes this program possible? Well, it starts with a vision, of course, but then it takes some innovation, some investment, the right people, and then making sure that the right people are collaborating with each other to achieve this vision. And we have various groups, and I understand there's acronyms here, but the utility plant, the building automation technology group, the energy management group, maintenance, the building business system analysts, and the planning and construction folks, they all work together in collaboration to make this program possible. With that, I will turn it over to Steve. I think he has a few questions he wants to.
Yes. That's excellent, Lilith. It is very impressive to see the broad scope of your responsibilities and at the same time the effectiveness of a lot of your initiatives. I would say that as you pointed out throughout your talk, it highlights to me the way that we categorize the value proposition of EnergyCAP falling in three main buckets. And I think you're a great example of how you're getting value out of all three of those value proposition buckets for energy information. The first value bucket that we talk about is accounting. And you're using EnergyCAP to process your incoming purchased utility bills. You use our bill capture service and the OCR platform to get those bills digitized and into your system very quickly and then audited. And then also on the accounting front, you're using EnergyCAP to create your chargeback bills for all of your auxiliaries, which make up about half of your campus. So that's, I'm sure, millions of dollars of utility business that you're running to get the recovery, the cost recoveries from all those auxiliaries. So that's the accounting value bucket. And then the second value bucket is energy management. And you showed some examples of the value of EnergyCAP in the cost avoidance process, doing M&V of projects to verify what the savings are, which is very helpful in getting the next project approved when you can verify reliably how much the savings was from the last project. And also the benchmarking, the EUI calculations, things like that all tie into the energy management value bucket. And then the third value bucket is building operations, more real-time operations. And you mentioned how you're pulling interval data into EnergyCAP so that you can use that in dashboarding and reporting and use that to look at efficiency of production in central plant, things like that. So you're a good example of those three different buckets of value being pulled out of EnergyCAP in some very effective ways. So with that bit of summary, let me move on to some of these questions that some registrants had posted when they signed up for it. The first one, what's the most challenging aspect of managing a campus's utilities consumption?
There's more than one, of course.
Yeah.
One of the big ones that we believe we have is competing interest of energy management with research programs and the complex buildings that we have. Couple others are to do with older equipment and systems and maintaining those building systems, I would say.
And do you find yourselves constantly fighting for funds versus competitive needs for funds? Or at this point, have you established a credibility so if you say this is a project we need to do, we get a sub 3-year payback and makes sense for everyone?
It's a mixed bag. Sometimes we are in a position where money shows up, but as a public university, we have to be good stewards of that money. And as you mentioned earlier, having a proven record with a project definitely helps with securing more funds for similar projects at different locations. But it's a mixed bag in terms of how successful we are, and also depends on the budget cycles of the state funding that we get.
Yeah, okay, good. Let's move on to the next question. How do you incorporate the insights you glean from the data into your building operators routine so that what you learn from EnergyCAP does not go to waste? I think that's a very key question. You want to pull as much value out of that data as possible.
Right. And as I mentioned in my presentation earlier, at this time we are not using EnergyCAP to do that specifically because we just started pushing our interval data into EnergyCAP. But in addition to the EnergyCAP program, I also mentioned we have a fault detection and diagnostic program through Iconics. And that's where we also push our data to their system, and their system has algorithms and rules that our energy engineers have written that allow us to flag any deviation from optimal operation and allows the control center that we have to respond to those as faults with prioritization.
Yeah. Oh, one thing that struck me is when you talk about the fault detection and the sophistication you have there, reminds me of a visit I had paid just a few months ago to Texas A&M, and I looked at their control center where they're doing the real-time 24/7 monitoring of systems all around campus, which was very sophisticated. It was like Strategic Air Command headquarters in Omaha, you know, back years ago, with all the panels circling the room and people sitting there and monitoring everything. So it struck me from these examples of the sophistication level of major universities. I would contrast that to a lot of our other clients, school district clients and municipal clients. We're really in a whole different category. Their buildings tend to be less complex. You have very complex laboratory buildings, for instance. Typical school district or municipal government doesn't have buildings that are that complex. And what we're trying to get across to the typical school district or community college or municipal building owner is that you can use interval data very successfully to recover some low-hanging fruit without a lot of effort. You don't need a control center and someone sitting there 24/7 monitoring all these different systems. What you need is a look back every morning at yesterday's interval data, and simply by looking at 15-minute interval data from yesterday or the past weekend, you can spot some things that can probably save you some money immediately. Just this morning, I was looking at interval data for a school district in Texas, and I noticed that in all 5 of their buildings, their highest peak for the entire day for the last 3 months, every one of their highest peaks was at 7 to 8 a.m. in the morning. Now, you would think in Texas your peak would be later in the day when air conditioning is maxed out and when lighting's maxed out and the kitchen's in operation. Well, it's simply an HVAC control issue where they're bringing everything on at once for the morning wake up, and because they're doing it all at once, they get this high spike first thing in the morning. So there's some simple things they can do to mitigate that. And another one was we're working with, well, one of the largest cities in the country and looking at their interval data from their city hall building, a building that most people would recognize on site because it's very iconic. We spotted something that their own operations people hadn't spotted, and that was the same kind of a problem. 5 a.m. was when they were hitting the highest peak of the day consistently because of this morning wake-up period. So what we're trying to present to a lot of our audience is you don't have to be that sophisticated with fault detection and 24/7 real-time monitoring. Start with just looking back at yesterday, look at your interval data chart, and you can probably come up with some good ways to save, grab some of that low-hanging fruit, and then as you go forward, you can fine-tune and get more sophisticated in it. Okay, yeah, let's move on to the, I'm sorry, we'll move on to the next question, but go ahead with what you were saying.
No, I was just going to say we agree, and you can't manage what you don't measure, and simple things like that can go a long way. In fact, that's where we started, honestly.
Yes, yes. It is a good place to start. Okay, next question. What is the usefulness of meters versus just the whole building or utility grade meters on new construction to determine how a building is performing compared to how it can or should perform? In your example, you had some very detailed metering of subsystems within the building when you were talking about the reheat control on that one VAV box. That's pretty granular tracking. So what would you say when you look at the cost effectiveness of the very granular tracking versus just whole building tracking?
So I want to clarify that those charts that I showed were not technically meters. They were just trend information about the building automation system points. Well, you can see them as meters if you want to think about it in that manner. So the reason we have all of those points information is because they would exist on any campus that has electronic DDC control centralized, which most campuses do anyway. And so we didn't really expend any extra dollars on making sure that all those points existed. They just existed for the fact that we wanted to control that space remotely anyway. So the difference we made was we started recording that on a regular interval and keeping that data for longer time. That allows us to go back in time and do some detective work, as you were mentioning earlier about the spikes on the school in Texas and Los Angeles, I think you mentioned. Yeah. So yeah, that's kind of where the benefit is. For the actual metering for billing purposes, we only have utility grade meters on building level.
And you have a central plant where you're producing electricity and steam and chilled water?
We do not produce any electricity. We distribute the electricity we get from our local provider, which is the Lincoln Electric System. But yes, we do produce steam and chilled water and distribute it all over campus. We actually have 2 campuses within 2.5 miles, and each campus has its own central utility plant.
And can you comment on how many individual auxiliary chargeback bills you produce a month and what the dollar volume is on an annual basis? Is that releasable information?
That's something I don't have off the top of my head right now, but I don't know if that would be proprietary information.
Okay, I was just curious.
Right now it would be about 200 to 300 bills. And you saw that our square footage is almost a 50-50. I would expect the dollars to be similar, except now auxiliaries include stadium and other athletic facilities that are bigger in square feet and non-operational during the year. So we may have less dollar usage there.
Right.
But
I think it was something like, it was 5 or 6 million square feet, I think, of auxiliaries, so I would think it would be something in the range of $10 million, $2 a square foot, maybe $1.50 to $2, something like that.
That sounds reasonable.
Yeah. Okay, well, let's move on to the next question. What are the best uses for weather normalized utility data? I think you showed us an example of that with the Quilt Museum EUI chart. That chart uses normalized data.
Right, and the thing that we used to struggle before we had EnergyCAP implemented was we used to have to do the heating degree day calculation and cooling degree day calculation ourselves, because sometimes if the weather is affecting my usage, even though my usage may be higher, I may actually be doing a good job, but I'm impacted by worse weather. And the flip side is sometimes true too. Weather was actually favorable, but maybe our energy management activity didn't work and our energy usage is actually lower. So in both those cases, we really love normalized utility data because it takes weather out of the equation. It allows us to compare apples.
That's been a challenge the last few years because we had 2 years of polar vortex where we had historically cold weather, and then we had 2 years of historically mild winter weather. And ours here in Pennsylvania is probably similar to yours in Nebraska because you send yours in our direction. And without weather normalizing, it was really difficult to determine year-over-year performance. So we've seen a lot of good use for that. Okay, let's move on to the next question. We have time for 1 or 2 more questions. Please discuss an example of setting up custom fields. I think that you have used some custom fields in EnergyCAP, and in what ways are they useful for you?
So a good example for us is whether or not a building is auxiliary or general education fund funded. So that's a very simple example. We could have used the tree hierarchy that EnergyCAP has to manage that, but we decided to not mess that up just for this. And so we ended up using the custom field that marks whether or not it's a auxiliary, meaning that we are going to recoup our costs versus state funded. So we could just very quickly accumulate all the costs associated by auxiliary buildings versus state. Another example that I can think of would be, so EnergyCAP also has a feature that allows us to push data into Energy Star Portfolio Manager. And Energy Star Portfolio Manager has certain classifications for buildings, and some of those don't necessarily work for us. But if we want to push the information to Energy Star, we didn't want to just keep putting everything in the other category. So we created another custom field that allows us to classify those buildings to our liking, and that's another example that I can think of.
Yeah, good. Well, one of the useful functions of the custom fields in EnergyCAP, as you're well aware, is a custom field can be used to automatically create a group of buildings. So you can say, look at this attribute, and based upon that, put the building in the appropriate group automatically, and if the attribute ever changes, the building will change to the appropriate group. And once you have all buildings with a like attribute in a group, that group can then be used as a report filter. So it's a very powerful method of being able to look at your buildings, look at buildings that have a common attribute very easily. Right. So we found those to be very popular.
We use that.
Let's go to, yes. Let's go into one more question. Please describe the resources you have dedicated to energy management. So you've impressed us with the breadth and the depth of your energy management and the sophistication, I should say, also of your energy management efforts. How many people is this? It's, I think, more than just you, right?
No, it's all me. I'm just kidding. So that's a difficult question to answer because from a purely energy management perspective, we have one energy manager, and he has 3 energy engineers working with him. Now, they are not necessarily only focused on the energy management aspects of their job. They also, because we have our own building automation system, they are also responsible for writing the control logic and program the systems when we have new buildings or renovations coming online. So those 4 people are not necessarily 100% dedicated to energy management. In addition to that, as I mentioned, we have a control center that has 3 people working in there. We don't have a 24/7 operation. We have only day shift, and then we have on-call process that rolls over on a weekly basis from one manager to the other that then responds to those issues. In addition to that, we have control technicians. If I remember right, I think we have 6 maintenance zones, and each zone has one control technician that is kind of capable of doing energy management-like activities or take guidance from the energy engineers and energy manager to perform control activities. We have one recommissioning manager who has a technician that helps do the testing and balancing. All of that said, then on the other side, as I showed in one of the original slides, that's the operational side of things. And then we have the support side of the equation where we have data analysts and business analysts who played a pivotal role in implementing EnergyCAP, for example. They were the ones that were driving the implementation efforts. And then they also work very closely with our business office folks that are responsible for actually sending the chargeback information and paying the bills and making sure the SAP integration is validated before it gets pushed over to SAP. So as I said, it's a little complicated answer than a simple number, position, and task.
But so you have quite a sizable team that all use EnergyCAP in some way, shape, or form. They have one aspect of it that probably is useful to them, whereas other aspects are useful to other people,
right?
But not to them. I have one final question, and that is Rose Bowl 2018. We know it's not going to be Ohio State or Michigan, either Penn State or Nebraska. Which one do you think will represent the Big Ten?
Oh, if I have to pick, I'm going to definitely pick Nebraska because it's state law. We can not pick Nebraska.
Yeah, I understand. That's what I expected. Okay, well, Lalit, again, thank you very much. Your participation has been very valuable, not just for us, obviously, but for our attendees and for those who weren't able to attend but will be listening to the recorded version later. I'm sure that there's some nuggets in what you said that will be of value to all of the listeners. We appreciate your attendance and your interest in EnergyCAP, and we wish you all the best this afternoon.